My name is Antar, and for LAB9 I created a circuit which basically uses an Arduino Uno, an ultrasonic sensor, a piezoelectric buzzer, as well as a servo to essentially map onto the processing screen where your hand, or in this case we have the 3D printed part, which is just a rectangle. And so basically what you do is the closer you get, it's going from 5 centimeters all the way up to 30. And so as you can see, it's very smooth. And basically when you hit one of the notes, it's kind of hard, right? But it plays a different tone on the buzzer. So it sends a PWM signal to the buzzer, and depending on that frequency, if it's red, if it's green, if it's yellow, it will actually play a different tone. So it's kind of hard, but it's fun to play. I missed that one. There we go. So basically in the code, you have to line it up almost center for it to work properly. And I found that when using my hand, it wouldn't be as accurate. So you can just and in the top of the screen, basically, you can actually see the X position of the paddle. And the closer you move it, right, so that's 0 on my MacBook, and all the way up to 1300, which is 1400, which is actually the number of pixels on my MacBook Air. So that's kind of how I map the distance. So this is basically 0 on the ultrasonic sensor. This is all the way up to 30 centimeters. And then you can use your hand to play the game. However, you need kind of a rectangular 3D printed piece in order to get the signal back more steadily. So if you see, right, my hand, it's not giving the ultrasonic sensor the perfect feedback. And so we can fix that with a rectangular wall. So I added a score system up here, which basically when the paddle actually hits one of the things, it actually will, in the code, it will update the score. And so as you can see, now you have a score of 4. So I basically had to create this base, which can sit still, is very stable, and then when you put it in front of the MacBook, this essentially becomes the trackpad for the cursor, which is really awesome. And then I added originally, I tried to make a really cool 3D printed spin coder, which basically uses a drone motor as well as an Arduino Uno to essentially deposit a thin layer on top of whatever sort of thing you wanted. So in our case, it would have been a pellet where you can deposit a thin layer substrate. This would have replaced ALD, which is kind of really awesome. But unfortunately, upon installing this potentiometer into the circuit, I wasn't able to actually get a clear reading from the potentiometer, which basically meant that the drone motor would spin uncontrollably, which is obviously not desired.